Bismillahirrahmanirrahim. Assalamu alaikum. My name is Numan Rashid and you are watching my YouTube channel Something About Statistics. Today we are going to discuss a research paper that's mine. It's original research paper named Topp-Leone Dagum Distribution Properties and its Application. This paper published by the Research Journal of Mathematical and Statistical Sciences under the supervision of International Science Community Association. This paper published on 20th January 2020. Basically in this paper I used Daigum distribution on the genesis of Topp-Leone type 1G class of distributions provided by Al-Shumrani et al. After introducing this distribution, I obtained some mathematical and basic statistical properties of the distribution. Incomplete arc movements, mean movements, mean deviation from mean deviation from mean, reliability, and incomplete measures of this distribution. From graphical point of view, I provided plots of its density and decreasing hazard rate with assumed parametric values. I use basically some different assumed parametric values and find the plots of this distribution. I can see that the hazard rate of the distribution is decreasing. I also find Rayleigh and Thesalis or beta entropy of the distribution. I examine both estimation method in which probability, weighted moments and maximum likelihood are included. In the end, I applied this distribution to check the accuracy, to check the superiority of the distribution or compare the distribution with other model of its submodel in which Burr, log Dagum, generalized Dagum, Lomax are included. I can see that this distribution is better fitted model on that data sets. In the end, I provided these data sets. If anyone who are interested to, I can provide these data sets. As for introduction, the Daigum distribution basically introduced by Camillo Dagum in 1970. He introduces three types of these distribution, which is called type 1, type 2 and type 3. This distribution belongs to Burr system of distribution introduced by Burr in 1942. Basically it's a Burr 3 distribution with additional scale parameter. If added, then the Burr 3 distribution becomes Daigum distribution. The PDF of the distribution is we use Gx instead of Fx because it's a baseline distribution in this research paper. So you can see that the Daigum distribution has lambda, beta, delta, basically three parameters of the distribution, and the CDF of the distribution is that, and the limits of the distribution is 0 to plus infinity. The Topp-Leone generalized model provided by Al-Shumrani et al. Is 2 alpha gx, g bar x, gx alpha and minus alpha minus 1, 2 minus gx. In the reduced form of this model is FTLG. TL stands for Topp-Leone, G is the generalized model, shows the generalized model. 2 alpha gx, where gx is the baseline distribution, and in this research paper the baseline distribution is our Daigum distribution, while the g bar x is the survival function because gx, capital Gx is the CDF of the distribution. It has additional parameter, shape parameter is alpha. So we just, to obtain the Topp-Leone Daigum distribution, we just insert the small gx and g bar x of the Daigum distribution in this model and easily obtain the Topp-Leone Daigum distribution. The PDF of the distribution is, while the CDF of the distribution is, you can see the CDF of the distribution is I highlighted. So it cannot be solved easily. So for this purpose I use the binomial expansion, and one can easily see that the binomial function expand. So the finalized or used function of this is the finalized form of the distribution I can show you, that is, and further I use this equation instead of other equations. You can see the plots of the distribution with assumed parametric values. Similarly, in this section I obtain the random number generator, quartiles, skewness and kurtosis with the help of quantile function. With the help of quantile function, what is quantile function? Basically it is inverting. If we invert the CDF of the distribution, we can obtain the quantile function, where u is a uniform random variable ranging from 0 to infinity. To obtain first quartile, we can put 0.25 instead of u, and similarly 0.5 for median and 0.35 for quartile. After that we can obtain quartile deviation, skewness and kurtosis, that is called Moore's kurtosis, given by Moore's. Earth moment, we can obtain the earth moment with this ratio mu r1, mu r2 and so on. Further I explain some interquartile range q1, q3 with some assumed parametric values, and this table is you can see on your screen. Similarly, with the help of these parametric values I obtain skewness and kurtosis. In this section I obtain incomplete earth movement, and these are by the simple integration I can obtain CV and mean deviation or average deviation from mean. Similarly, reliability properties, from the basic reliability properties I obtain survival reliability or survival function, hazard rate function with this ratio, and so on, mean residual life, and finally mean residual life is you can see that is the ratio of survival function and this integration, and this integration can easily obtain. You can see my research paper. I can provide a complete link. In this video I just introduced this paper. Similarly, incomplete measures incomplete measures are very interesting, used in econometrics and economics, and basic position of the Dagum distribution or basic use of the distribution is in economics or income size distribution. That is, basically it is an income size distribution, and these measures, incomplete measures, are not only used in economics but also in demographic and other fields. So Gini index is also used in economics and other purposes. So that is the relation of the Gini index. I obtain Gini index. In this there is a plots of the distribution, hazard rate plots, Gini index and so forth, Pytra and so on. These are the measures of the distribution. The Salis entropy, Renyi entropy are the also part of this research, probability weighted moments and so on, MLE. Lastly, I applied 4 application of the distribution, which are very interesting. 4 data set, data 1, data 2 and data 3. If you interested, I will provide these. Finally, I compared this distribution with two more distribution in which Topp-Leone Daigum, log Daigum, Burr, generalized Daigum, Burr 3 and so on. L cap is the likelihood, AIC, BIC, CIC and Anderson-Darling test and one numeric test and cross correlates test, p-value of this test. And introduction of this model, Kolmogorov-Smirnov test. A stands for Anderson-Darling test, Cromer-1 Mason's test, and p-value of this function. So this function basically I used from Basically, I used this function from R language, which is easily available on Google search, and use the advocacy model package with algorithm LBFGS. You can easily download this model from this link. So this function provided us log likelihood function, AIC, CIC, BIC, Bayesian information criteria, and goodness of criteria basic tools I can obtain from this function. So table 3 comparison measure of the distribution of the first data set. You can say that Topp-Leone Dagum distribution has 1035.93 has minimum log likelihood value. AIC value is also smaller as compared to other distributions. Similarly, BIC is also smaller, while A Anderson-Darling Kramer von Mises test is also smaller value. Kolmogorov-Smirnov value is also smaller, while the p value of the distribution is greater as compared to other, which indicates that the distribution is better fitted. In the same sense, I use this distribution to the data set 2, data set 3. In this table I obtain some standard error of the parameters, which also provided by the function, a goodness of fit function, alpha cap, beta cap, lambda cap, and delta cap of the distribution. Similarly, it is applied for data sets. In the end, I obtained the graph of fitted distribution, and one can easily see that the Topp-Leone Dagum distribution is better fitted measure of distribution to the as compared to other distributions in which Daigum, log Daigum, generalized Daigum, and Berkeley distribution are included. So the distribution is better fitted distribution as compared to other distribution. In the conclusion, I explain the summary of my research. The reference you can see very important of that research. And if you are interested to read my research paper, I will provide that is the link of that paper in description box, and you can find or you can search easily. That is parameter estimation by maximum likelihood method, likelihood function, and then integrate and then differentiating this function with the help of parameters that is estimated. So alpha differentiate with respect to alpha, with respect to beta, with respect to delta, and similarly with respect to delta, and we can obtain the ML estimate of the distribution. These ML estimates cannot be obtained without any software. So for this purpose I can use R software, MATLAB, SAS software to obtain the numeric value of that estimators. These values are beyond our research. I cannot obtain these values. Furthermore, you can also find the Fisher information matrix and obtain the 100 into 1 minus alpha % confidence interval of the parameters of the distribution. So it is a further part of the research. Rayleigh entropy, Thesalis entropy, plurality weighted moments, and all other measures I obtained from of this distribution. So it's a little bit introduction of my research paper. Through this research paper, basically I want to introduce some basic tools or basic information about the distribution theory. One more research paper I will discuss with you on upcoming videos, the Topp-Leone compound relay distribution. 2 paper will also in pipeline and will be published on this month October. Inshallah, I will discuss with you. So keep watching my channel. Thank you very much. So please, if you interested and if you like my videos, subscribe my channel, promote my channel. It's not mine, it's your channel. and through this channel we are learning something about statistics. Basically my channel name is something about statistics. It's not something, it's all about statistics. If you are interested, I will provide maximum information and will share maximum information with you. Thank you for watching.